Hey, hi. In this video, we will see how to use node affinity using Karpenter on AWS EKS. So here, I'm going to create an AWS EKS cluster. In that EKS cluster, I have already configured Karpenter. So with using the Karpenter, how do we, we actually experiment how does the node affinity works here? In the sense, we will define a pod deployment or basically an application deployment with a certain, the node affinity definitions. Then eventually we see that and how does the Karpenter reacts to that particular situations where it will find that there is a pod is being deployed and which is in a pending state, and it is actually in a pending state because it is demanding a part, basically a node affinity. In the sense, the deployment contains a node affinity. So in such situations, basically Karpenter automatically spins up a node called node A with a required pod affinity definitions from the scheduled pod. Likewise, it also actually deploys the further the nodes according to the demand of the pod affinity from the pod. Okay, so in total, once the node is been spinned up in response to the the pod affinity definition, so in that case, it will try to schedule that particular pod to a destination created nodes, and eventually pod gets scheduled in that nodes as you see here. So we have a pod, and the pod has a pod affinity definition called, it needs a node with a label called dev1, right? So in that response, Karpenter has spinned up EKS nodes with the label called name equal to dev1. So in that case, it will automatically schedule that particular pod, which was in pending state earlier. Now it got the space, in the sense it got a hosting environment where it can run actually, right? So likewise, you can see that in response to the other type of pod affinities, the Karpenter tool will actually create a required nodes in that node pool, and which will elevate basically, which will enable the pending pod to get scheduled in that particular node, right? So under the hood, what do you learn here is node affinity is a definition that you can declare on the, or you can specify in the deployment, which actually creates a pod, and in on that pod you will specify a rule saying like this pod has to be scheduled to a particular node with a certain label or certain configurations, right? So here we will see this scenario. How does Karpenter help us to achieve the node affinity for a particular pod, right? So with that note, let me take you to my AWS account where I have created an EKS cluster. So this is my AWS account. Currently I'm in Oregon region. So I have created a EKS cluster with using kubectl utility. You can watch my previous videos on EKS where I have spinned up the EKS clusters with using kubectl. So now my cluster is being created, that is of version 1.229. Yeah. So once the cluster has been created, let me take you to my the VS code where I have I'm showing the the required part of the demo here, right? So basically, what do I do is, as in my videos, I have created a help file. So help file contains a set of commands that you need to follow to achieve the lab session, or basically to achieve the lab scenario. So here we are experimenting the node affinity in the Kubernetes world, right? So for that case, so this is the part where you need to create a cluster. I have shown how to create a cluster in my previous video. You can watch it from there. So once the cluster is created, so we will go to the top here. First one is basically, as you see here, we're going to create we're going to set the context of your AWS account, right? So since we are using the CLI, I'm using the AWS CLI to set my AWS account context. So this is how I do it. That is command AWS configure, which means that you need a CLI, AWS CLI as a prerequisite. So the AWS account context is set. To validate whether I have set the context, but I can run a command called AWS STS get caller identity, which means that it will check which identity has set the context. So here I am user identity it has a context, and note that that particular user has to have the permission on the EKS cluster, then only you can run the next command. That is a second criteria, right? Then what I'm doing is I'm just updating the the kubeconfig file. Basically kubeconfig file is nothing but it's basically authentication file which needs to be updated with the required the tokens, required credentials that is required to take access of your EKS cluster API server. So here we are using command called AWS EKS update kubeconfig and providing the Kubernetes cluster name, which will actually update your kubeconfig file, which is present underneath this path. And then from there, you can interact with the the Kubernetes API server with using kubectl commandlet. So here kubectl is also becomes a prerequisite here. You need to have a kubectl installed in your system. Then we are running a command called kubectl get nodes just to check whether I can interact with the API server. So I can interact with the API server something like this. Okay. And next one, so next prerequisite here is you need to have a Karpenter configurations installed in your system. Remember that Karpenter is an additional infrastructure layer on the Kubernetes cluster like EKS, right? So which actually helps you to manage the lifecycle of your complete cluster, right? So when I say lifecycle of your complete cluster, it also helps you to at a different level. One is at a scaling level, that is it has a capability to automatically scale. It has a capability to act according to a certain criteria, like it will help you to achieve the node affinity. It will help you to achieve the other scenarios of required to manage the lifecycle of your the Kubernetes cluster. And Karpenter is basically pack up that, in the sense it's basically provides all that capability from a particular particular component called Karpenter, right? So we have installed that infrastructure layer on the Kubernetes cluster, and that is becomes a prerequisite of this demo. So from there I can show you that how does the node affinity works with the in conjunction with the Karpenter, basically. Yeah, how does the Karpenter helps you to achieve the node affinity of your application. So that is the basic basic concept of this demo. So here I'm just checking whether I have installed the Karpenter or not. So to help you to install the Karpenter, you can watch my another video called AWS EKS Karpenter, right? So where I have explained in detail like how to host the Karpenter on the EKS cluster. Even on top of that, I have given the commandlets that you need to follow to enable the Karpenter on your EKS cluster, something like this, right? So once you are here, right, so which means that once you are done with this, now we are actually validating here, that is whether the Karpenter is installed or not. So you see that we are checking the Helm list Karpenter, which is giving you the response of the install, and then you can check the parts of the Karpenter. So you see that parts of the Karpenter are running fine. And then you have get deployments underneath the namespace called Karpenter. You see that it is also working, right? Okay, on top of that, note that so currently my cluster has 2 nodes. Okay, remember that my cluster had 2 nodes, and these nodes are type something like T2 extra large. Yeah, next one. So now we are all set, ground is set. Now we can experiment the node affinity of a particular part. So how does that Karpenter helps us to achieve that? So for that case, what I did is, for this demo shake, I have already created a folder, and these are all the basically we need to run only 5 commands. Okay, so for this demo, we are dealing with only 5 commands with a great explanations here. So we have a folder called node affinity. So I'm going to cover up the other capabilities that Karpenter provides. So here we are looking at node affinity capability that Karpenter provides us. Okay, so here this is the folder. I'm going to share all these files needed for this demo purpose. You can try to do it from your side. First one is we need to install the node affinity configurations on this EKS cluster. What does that mean? In the sense, if I open this node affinity.yml file, basically it creates the Karpenter the objects. So Karpenter also needs an object to deal with a certain the use cases of the Karpenter, right? In the sense, Karpenter is basically a foundational layer or foundational infrastructure layer. On that one, you need to install the capabilities like node pools and the ECS node, something like that, which will actually help you to achieve the scenarios like part affinity or node affinity here. So in that perspective, we need to create a node pool here. In the node pool, you see that it creates a node pool that is needed for Karpenter. Right, it has a metadata specifications are there. You see there are the specifications of disruptions limit, that is basically CPU limit up to 10 core CPUs, and it has the template metadata labels, basically in the sense it actually creates a node pool with these labels. Remember that we are using the label called EKS immersion team equal to my team. I have just taken this file from the AWS documents, because where they have created a workshop. So I'm just demoing that workshop in a real time here. So we have a specifications like this, right? So and then here are the requirements. So basically it says that it can create the nodes, or basically nodes in a node pool out of these requirements. What are all those requirements? One is instance category, which are belongs to the AWS is instance categories from CMR. Basically they're all categories of EC2 instance. And then the Kubernetes architecture belongs to AMD 64, and capacity is basically on demand, like that. Yeah. And the another object that it is creating is EC2 node class. So what is the EC2 node class it has to create? Okay. So here is the basically definitions of the EC2 node class object. So once you are ready with the Karpenter, you need to deploy this particular file. Yeah. Or basically we need to deploy this particular file so that it creates the a node pool and EC2 node class, which is needed for node affinity purpose. So I just deployed this particular file running a command called kubectl apply hyphen apply, kubectl apply hyphen file name, and it created the the two objects in the cluster, right? So with that options, my basically my EKS cluster Karpenter is now ready to deal with the the node affinity aspects. Okay, so immediately we will go and test that. So how do I test that? Basically I have one deployment example file, basically two deployment example files, which is dealing with different types of node affinity. First one, node affinity deploy. So if I go to the app, so right now we are deploying node affinity deploy. So what is this node affinity deploy? Is basically, as you see here, it is proper Kubernetes deployment file or proper Kubernetes manifest file, which will deploy an application. In a very layman term, it creates an parts of your application, right? So in this one, you see that we are actually have a metadata of inflate workshop. It will be created in a workshop namespace. Remember to create a workspace, or basically namespace with a name called workshop. So then only you can, this deployment can go green, or basically it will be successful. Here I have created the namespace workshops previously, so I have not added that command to create a workshop namespace. So you need to run a command called kubectl create a namespace, and the name of the namespace is workshop. And then this deployment has a replicas of 3, and the selectors is basically, this is basically app selectors, that is inflate, app equal to inflate, and then the template, basically application template, is something like this. So again, in the metadata you have the labels of app equal to inflate. In the specifications, basically here is the this is basically termination grace period equal to 0, and the containers, basically from where the image is being pulled and how does that image should be created. So that is where the container definition talks about. So this is the container name equal to inflate. The image has been pulled from this public image. We have a resource definition of having a CPU reservation of 1 core processor. And then this is where we actually deploy the node selector. If you go here, if I minimize it, so basically underneath the specification definition, right, underneath the basically template, underneath the template of your deployment, you have a property called specification. In that specification property, you need to define a node selector. In the node selector, you are telling, hey, I need to deploy these application parts on a node with a label key called EKS immersion team and value equal to my team, right? So once I do that, basically, what else happens is, if I go back to the previous deployment, that is node affinity. So here we created the, if I go above. So here we created the node pool with the labels called EKS immersion equal to my team. Basically, so Karpenter has a capability that it can spin up the node nodes in a node pool with a label called EKS immersion team equal to my team, like that. Yeah. So now what we do is, we have deployed this particular applications with this particular definition, that is node affinity equal to deploy. And then suddenly I have the next command, that is basically check what does that Karpenter does in such a response. Okay, remember that at this stage of my cluster, there were node groups was there, but that node group contains the nodes without any labels, right? So in such cases, you should be able to see the logs in the Karpenter namespace, something like this. If you go to this one, so it says that, if you see the message, could not schedule the pod incompatible node pool. So I have the default node pool, and that node pool does not contains any kind of labels called EKS immersion team equal to my team, right? So here he writes, the requirement says that EKS immersion team and value should be in this my team. Okay, basically it is trying to find out find out the nodes to schedule the pods of the particular node affinity deployment. And then if you show that you could not schedule, basically then what it happens is, basically it will invoke a command called created a node claim. You see that message, created a node claim of certain configuration, something like this. Yeah. And so you should be able to see a message called node claim, which means that there are node pools, but those are all not suitable for the particular deployment. So I need to spin up the node pool of a certain criteria. So then what happens, Karpenter invokes a command called basically it actually, yeah, let me go back. So basically it actually invokes Karpenter automatically invokes the command which will actually spin up the EKS node, that is additional EKS nodes, and then it will tries to schedule the parts, right? So automatically it has spinned up the extra the nodes. So, right, so and it is, you see that our inflate the parts we're able to running now, right? So if I go back to the my AWS account and go to the EC2 instance, right, if I spin up this one, if I refresh it here, you should see that there are three nodes. Okay, so one is default node group nodes, that is see that the node names with the node group equal to node, and the other one is spinned up by the Karpenter. So basically my parts are running in this particular nodes now, right? Why? Because that nodes has the that node has the the tags. So if I go to the manage tags, and I'm not sure whether it is available, if you see here, right, so it has these many the tags, which is basically tagged by yeah, these are all the tagged by basically the EKCTL, yeah. And also some this is the part which is created by the Karpenter, so it will have a different tags. If you go to the tags, you see that managed by Karpenter, yeah. Okay, so if we try to do a command called kubectl nodes here, we should see three nodes. Okay, earlier on top of this one, so if I go down top on the top, we had only two nodes, right, underneath the node group definition of initial cluster creation. Now the node group number got increased. Okay, let's see if we can see that. If I go to the kubectl get nodes, here you go, right? So we have we have a three nodes now. Okay, so now we have seen that the Karpenter can, if I go back to the diagram, now Karpenter can respond to a demand from the the pending pod, saying like, hey, I need a pod of certain the labels. Okay, then in response to that particular this Karpenter went and spinned up a node with a label something like this, which is matching to this pod affinity definition, and then it got scheduled here, in the sense node affinity got scheduled basically, yeah. It should be node affinity, so I'm just going to say it as a node affinity, right? So this is basically node affinity. So according to that node affinity, these pods got the deployed in this particular node A. All right, so now let's see the another definition. So if I go back to the another definition, now we have seen with the labels. Let's see another scenario where you might need to schedule the pod with a certain node configurations. So in such cases, what we do is we're going to reframe the constraint of the deployment. So if I go to this one, so this is the file called constraint deployment. This is basically a same file. It is actually deploying the same application with a different the node affinity definitions, right? So if I open the node affinity deploy here, right, so here we had a node selection equal to this, but in this one, that is actually constraint deployment. So here you have a extended node affinity definitions. You see that node select equal to this one, but but if you see that in the specification affinity equal to node affinity, in the node affinity it says required during scheduling the ignored pod. Okay, then it is actually saying that the node selector is basically matching to the particular, like m6a dot extra large. Okay, so currently if I go to the to this particular part, so I don't know, so basically this is c6 extra large. Okay, so now what we do is we're going to create a three more we're going to create a three more parts, which is actually demands a nodes with a certain configurations, that is basically instant type equal to m6a dot extra large. Okay, so for that case, let's deploy this file. So what I do is I'm going to deploy this file, something like constraint. So let me deploy this file now. It is basically constraint deployment. So what had happens is basically it creates the extra parts. Okay, so let's check the parts now. So if I run the command called kubectl get parts, remember that so don't get confused. So here we're actually creating the extra parts in a different the different with the different configurations. Okay, basically in a same workshop, in the same namespace called workshop, but it has a different configurations. you see that here, so we had yeah, so the number of replicas equal to 3. So if I can open this again, run it again, we should see basically container creating. Yeah, so it is in a creating mode. Now we can check the logs basically. So why it is replica equal to 3? So yeah, earlier it already had the replicas, because basically I'm overwriting it. Yeah, in the sense, if you go back to the node affinity definition, so it also had a the same definition. So that is, yeah, not this one. So the other one, that is node affinity deploy. So wherever file name ending with deploy is basically a deployment file. So earlier we had a 3. Now constraint deployment, in the sense we now slightly tweak the constraint of pod scheduling to something else that is containing the instance type. Now we should see how does that Karpenter respond to this one. Yeah, so again, to check that, you should be able to check the logs. So let's check the logs. So I'm going to check the logs quickly and see that how does that Karpenter is responding to this one. So if I see the logs here, so here you see that it says you should see that there is a disrupting via emptiness. Okay, we should see something, a message called node claim, right? Generally in the logs, generally you see that node claim should be the message. I'm trying to check here. So delete basically message, delete the node claim, deleted node claim, so tented nodes basically, then command succeeded. Yeah, so let's see if it creates the basically so you want to study the logs, basically you can extract the more logs from the Karpenter. But eventually what I'm expecting is it should create a node with a different configurations. That is basically M6A large. Okay, so basically what happened is it has the deleted the nodes, basically previous node, and it has created a new node with a new definition that I have defined in the modified deployment. Okay, so remember that I'm using a word. So the node affinity deploy.yaml file is a version 1. Constraint -deploy is basically version 2 with a different definitions, right? So how does that Karpenter respond? Basically it has spinned up the the dev tools. Consider something like this. Okay, so we saw that it got deployed here. Now it is able to deploy here as well. So something, if I can draw a diagram, so earlier it had the definition. Now it is deploying to this from this cluster to particular this cluster. Okay, so this one. Yeah, so this is basically the later, this is what it happened. So I'm going to mark it with a cluster particular color, right? So now what we do is we're going to go back to the refresh it. So here you see that we had a new the EC2 nodes with a different configurations. Earlier it was C6A dot extra large. Now it is M6A dot extra large. So M6A dot extra large is basically in a constraint deployment definition. So if I open this one, so here we demanded M6A dot extra large. Okay, now you try to see the kubectl get pods, and we should be able to see that all pods are running. So if I do a minus, and let's see from the fresh. So now what I do is I'm going to get the pods, and we should see all the pods running. Here you go, our pods are running. In the sense, what we did is earlier we had a 3 the 3 replicas. So those 3 replicas are now migrated from old node, that is C6A dot extra large, to M6A dot extra large. Now we should be able to see the nodes number also to the 3 as well. So if I run the nodes, right, so here we have the node. Okay, so you can also check the logs of the Karpenter. You should see that the parts are scheduled something like this. Okay, all right. So with that note, I have shown you the things need to be shown in this particular video, that is for node affinity perspectives, how Karpenter helps us to achieve the node the affinity at a different cases. All right, so with that note, thank you very much for watching my video. Kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.